Okay, guys, in this lesson, we're going to talk about squares, cubes, and their roots. So let's talk about a perfect square number. A perfect square number is when we have an integer, negative or positive whole numbers, and you multiply it by itself, you create a perfect square number. So an example that we have here is 8 squared, which is 8 times 8 is 64. Therefore, 64 is a perfect squared number. So let's talk about where we get the word square number, perfect square number. So the formula for the area of a square. So the area of a square is the length times the width. Well, since a square has same sides all around, we can say that the area is the side squared. So in our example, if we have the square that has dimensions in 8 by 8, 8 lengths all the way around, the side length is 8, and then we have 8 times 8, so the area is 64. So let's get a different color here. So the area of this square is 64. So the area of squares are perfect squared numbers. So let's go through the top perfect squared numbers, the first 20 to 25. And these numbers we need to be really familiar with. So this square has a dimension a 1 by 1. So 1 is a perfect square. 2 by 2, we have a perfect square of 4. 3 by 3 is 9. A 4 by 4 is 16. 5 by 5 is 25. A 6 by 6 square has an area of 36. 7 by 7 is 49. 8 by 8, 64. A 9 by 9 square has an area of 81. 10 by 10 is 100. 11 by 11 is 121. And a 12 by 12 is 144. So all of these numbers, these areas, are perfect square numbers, and we need to be very familiar. So let's continue. A 13 by 13 is 169. A 14 by 14 is 196. 15 squared is 225. 16 squared is 256. 17 by 17 is 289. 18 times 18 is 324. A 19 by 19 is 361. And a 20 by 20 is 400. And 21 by 21 is 441. And then we have 22 times 22, and that gives us an area of 484. 23 by 23 is 529. And then we have a 24 by 24, and that area is 576. And the last one we need to be familiar with is a 25 by 25, which is 625. So all these areas are perfect square numbers. That means we took an integer, such as 25, and we multiplied by itself, and we got this product. So let's talk about the inverse of squaring a number. So we just multiplied all of those integers by itself. We raised it to a power of 2. So we have 4 squared is 16. 4 times 4 is 16. And to undo something that we squared, we take the square root. So taking the square root, we have a radical symbol that we will talk about. So 4 squared is 16, and then the square root of 16 gives me back the 4. So you're getting back the base of the number that you multiplied. So that's what taking the square root is. So a radical expression simply contains a root. So we can have the square root of 16. That means what times what? We multiplied something 2 times. That's what this index tells us. Gave us 16. So the square root of 16 is going to be 4. We multiplied 4 times 4 to get the 16. We can also have cube roots where our index number is 3. That means we had a number, an integer, multiplied by itself 3 times to give us the product that's under the radical. So the cube root of 27 is 3 because 3 times 3 times 3 gave us that radical 27. You can have a fourth root where we multiplied a number 4 times by itself, and this number would be 3. 3 times 3 times 3 times 3 is 81. So the fourth root of 81 is 3. So for this course, we're mainly going to be just looking at square roots and cube roots. Now let's take a look at what a radical expression, all the parts. So we have a coefficient, just like if we had 4 times a, 4a, 4 is your coefficient, 4 times a. So if we have a coefficient other than 1, there will be a large number out here. In our examples up here, we had an understood 1 as our coefficient. Then we have the index. This is the little subscript, okay? It is what was how many times the root was multiplied to get the radicand. So when we take square roots, the index is 2. The expression under the radical symbol is called the radicand. So up here in our example, 16 is a radicand, 27 is a radicand, 81 is a radicand. So those are the parts of a radical expression. So again, we're going to focus mainly on square roots, and so our index is going to be a 2, but many times we don't use the index of 2, we don't write it, so it's understood to be a 2. So most of the time, we're just going to say radical, without an index number, but it's understood to be a 2. So if we're going to take the square root of 81, we're asking ourselves, what times what gave us this 81? And of course, that is 9, because 9 squared is 81. So the square root of 81 is 9. The square root of 25 is 5. 5 times 5 gave us the 25. The square root of 49 is 7. The square root of 400 is 20. 20 times 20 gives us that 400. The square root of 225 is 15, and the square root of 100 is 10. So this is one of the reasons it's very important to have your perfect squares memorized so I can easily identify the roots. Now let's talk about taking the square root when we have a coefficient other than the understood 1. So in this first problem, this is saying 3 times the square root of 64. The radical acts like parentheses in order of operations, which means we need to take the square root before multiplying. So this is 3 times the square root of 64, which is 8. So this gives us 24. 5 times the square root of 9, and the square root of 9 is 3. So 5 times 3 is 15. 2 times the square root of 121 is 2 times. The square root of 121 is 11. 2 times 11 is 22. Negative 2 times the square root of 36, which is 6, is negative 12. Negative 3 times the square root of 144, which is 12, is negative 36. And negative 5 times the square root of 81, which is 9, gives us negative 45. So when you have a coefficient other than 1, you simply take the square root first and then multiply it by that outside number called the coefficient. So let's talk about how every perfect square has 2 roots, meaning there's a number you can multiply by itself to get 36. So we know that 6 times 6 is 36. So positive 6 is a root. But remember, when we square any number, we get a positive product. So if we have negative 6 times negative 6, we get positive 36. So the 2 roots of 36 are positive 6 and negative 6. And we usually use plus or minus symbols to represent these 2 solutions. So when it asks you to give the 2 roots, this is the answer you're going to provide. Or if you're solving an equation. So in our first example here, we're saying what could x be that if we square it, we get positive 25. So remember, taking the square root is the inverse of squaring. So to get rid of an exponent of 2, we can take the square root. So taking the square root undoes squaring, leaving us with x. Just like adding undoes subtraction or division undoes multiplication, taking the square root undoes squaring. So if I take the square root of the left, we know that we have to take the square root of the right. And because every square number has two roots, we're going to use the positive and negative symbol. So when I take the square root of 25, I get 5. So x could be positive 5. 5 squared does give me 25. It creates a true statement. But also negative 5, if I have negative 5 and I square it, I put that in for x. Do I get a true statement? Well, negative 5 times negative 5 is 25. So we do indeed get a true statement. So when we solve equations, so such as this next one, we're trying to know what could x be that equals 36. So we're going to undo the squaring, Positive or negative 6 is my solution. So I have two solutions. The square root of 81, we're going to take the square root of both sides. We're going to remember that every perfect square has two roots, a positive and negative 9. X squared equals 100. What could x be? X can be both positive 10 and negative 10. What can x be to make this equation true? X could be positive 15 or negative 15. And then when I solve this equation, x could be positive 3 or negative 3. So just remember, every perfect square has two roots, the positive and negative root. Now let's take a look at some word problems. So we're going to do a sketch each time we do a word problem. Drew fenced in a square area for his dogs Lola and Lucy. The area was 625. So inside we have 625. And now we want to know how much fence did he need. So if the area is 625, the side is the square root of 625. And we want to know how much fence, which is the perimeter of this square all the way around. So the square root of 625 is 25. So there's 25 feet going all around the square. So perimeter is going to be 4 times 25 feet. So the perimeter is 100 feet of fence. So remember, perfect squares represent the area of a square. And to find the length, you take the square root. Debbie planted gladiolus around the area of her 324 square feet garden. How many feet of gladiolus did she plant? So all around this perimeter, she planted some flowers. And the area inside is 324. So the side length, we undo the area by taking the square root of 324, which is 18. So all four sides, feet, she planted 18 feet all the way around. So the perimeter is 4 times the 18. And so we multiply 18 times 4. 8 times 4 is 32. 4 times 1 plus 3 is 7. So 72 feet of gladiolus. Taylor placed a border around her 400 square foot sunroom. How much feet or how many feet of border did she use? So again, inside, there is 400 square feet inside here. To get the side length, we take the square root to get back what each side was, what was multiplied, what times what gave the 400, and that's 20 feet. So she has 20 feet of border on all 4 sides. So we're going to say 4 times 20. We'll go ahead and change this back so we can see that a bit better. So the perimeter is going to be 80 feet of border that goes around all 4 sides of her sunroom. So now let's talk about perfect cubes. So cubing a number, multiplying it by itself 3 times creates a perfect cube. So 4, so if this were 4 cubed is 4 times 4 times 4, which is 64. So 64 is a perfect cube number. Just like square roots represent the area of a square, so a square root such as 4 by 4, so the area is 16. 16 is a perfect square. A perfect cube represents, I'll do my best to draw that cube, represents the volume, so it's 3-dimensional. So this, if the face is 16, 4 by 4, but the volume 4 by 4 and then another 4 to get the depth, the volume is 64, and that is the volume. So perfect cubes represent volume, perfect squares represent area. So let's be familiar with perfect cubes. So 1 times 1 times 1 is 1. 2 cubed, the volume of this is going to be 8. The volume of this cube is a 3 by 3 by 3, 27. A 4 by 4 by 4 is 64. So those are all perfect cubes. A 5 by 5 by 5 is going to be 125, a perfect cube number. A 6 by 6 by 6 is 216. 7 by 7 by 7 is 343. And then we have 8 by 8 by 8 gives us 512. Again, these are all perfect cubes. A 9 by 9 by 9 is going to be 729. A 10 by 10 by 10 is going to be 1,000. And then 11 cubed gives us 1,331. And I'm not saying memorize all of these ones, the larger ones, but just be familiar with them. And then 12 cubed is 1,728. Double check that. Okay, so when we take the cube root, our index does have to show a little 3. Okay, the only root that doesn't have to have an index is when we take a square root. So we'll just take the cube root of 27. So what times what times what gave us the 27, and that would be 3. The cube root of 8 is 2. The cube root of 125 is 5. The cube root of 216 is going to be 6. The cube root of 512 is going to be 8. And the cube root of 343 is 7. So that's how you take a cube root. So I hope this helps you.